Hello everyone. Today is day 4 of Leetcode 75 challenge. Let's begin with the fourth question. Question number is 605. Can place flowers? The level of the problem is easy. I would request you to read the question beforehand as I will directly deep dive into the PPT and explain you the question in much simpler way. Okay. So what problem says? Problem says that we have a flower bed represents with an array of zeros and ones. Okay, understood. Zero means plot is empty. One means the plot already has a flower. Okay, easy. Flowers cannot be planted in adjacent plot. No two ones can be next to each other. So 0, 1, 1, 0. So this cannot happen. You need to check if n new flowers can be planted in the flower bed without violating the rule. Okay, so we have been given an array consisting of zeros and one, and one means the array is the place is already filled. Zero means the plot is empty, and we are given a value n, which means that we have to plant that n number of plants into the array if it is possible or not. So what is the constraint? Constraint says that the flower bed length would be from 1 to 2 to the power 10 to the power 4. Okay. Flower bed values will be 0 and 1. There are no two adjacent flowers in the flower bed. It is mentioned earlier. So there is no 1 adjacently present in the flower bed. And flower bed length given value would be from 0 to flower bed length. Fine. Great. Now let's understand the input and output. So first input is given as 1, 0, 0, 0, 1 and n is 1. So we have to insert one flower in this array and the output is true. Okay, how? Because 1, 0, 0, 0, 1. Okay. Now condition says that we have to plant this flower into this array, but it should not be adjacent. If you try to plant one here, it is adjacent to this. Okay, this cannot happen. So this cannot be done. So yeah. Okay, we can plant the flower one here. Yes, possible because these two are not adjacent. That's right. But if you try to plant the flower in here, it will be false. So not possible. So yeah, that's why this returns true. Now the same array is given here, but n is 2. Okay, let's try why the output is false. 1, 0, 0, 0, 1. N is 2. So we'll first take one flower and we'll put it here. Not possible. Here. Okay, done. So it became 1 now. Now we will take 1 again and no, we cannot put it here also. It is already occupying and we cannot put the one here also. So we cannot use all the n flowers given. So the output will be false. So this is what input is given. Now, what would be the intuition of solving this problem? Imagine you have a row of chairs lined up for a group of friends to sit on. Some chairs are already occupied while others are empty. However, there is a rule. Two friends cannot sit next to each other because they need personal space. Now, you're given a certain number of new friends who need to place to sit. Your goal is to check if you can sit all of them while following the no adjacent sitting rule or not, right? How we will figure out this thing? We will look for the empty chairs, which is basically zero in this case in the flower bed, where a new friend can sit. Ensure that the chair on the left and the right is also empty because or does not exist at the boundary. If a valid seat is found, place the friend there, basically changing the 0 to 1 in flower bed, and repeat until all new friends are seated or there are no more valid spots. At the end, if you manage to seat all the new friends, return true, otherwise return false. So I hope you understand the intuition what they're trying to say that if they have a number of chairs here, let's assume this client as chairs and let's assume this as friend sittings. So if there is one friend, if he is a friend of him, he cannot sit here, but he is not a friend of him. So he can sit here, right? So understanding this concept in this way, we can solve the flower bed problem. What is the approach? Let's deep dive into the approach. First, we will keep a count variable. Why? Because at the end, we have to check whether this count matches the n so that all the flowers have been used or not. Okay, understand. Now, second, we have to loop through the flower bed, and for each plot of the flower bed, we will be checking that if if it is empty or not. Right? First, we will check if uh, left neighbor is empty. If the I equals to 0, which is the first plot, it has no left neighbor, right? So if it is here in the starting index, it does not have any, a neighbor to it. So it automatically becomes valid. Okay. But if there is some neighbors, let's say there are some neighbors, okay, and then we're gonna check that if this is 0 or not. If it is 0, then also it is valid, because if you're placing something in between, it has to be this way, right? So if you're going to place it here for the left, we're gonna check whether the left side is 0, or if the checking index is the first index itself, which is this. Similarly, we will come to for checking to the right side neighbor. First, we will gonna check that if uh, if it is the last index or not. If it is the last index, then also it is a valid, right? Because if something is here, x, y, z, and we're gonna place something here, so of course it becomes valid, right? And if it is not the last index, if it is somewhere in the between, like here, we're gonna check that if I plus 1 is 0 or not. If it is 0, we can take that, and we're gonna mark this both variables as true, and then we're gonna check if both are true or not. If both are true, we're gonna increase the count by 1 and modify the flower bed and insert 1 there to show that we have planted a flower there. And we're gonna loop again and gonna check it again and again, and we keep on continuing until the flower bed array ends. And at the end, we're gonna check if the count is greater or equal to n. Then we're gonna return true or have been planted. Otherwise, we're gonna return false, hence everything has not been planted. So this was the approach, clean and simple, nothing to worry. We just have to check whether the left neighbor is the starting index or left index is 0. Similarly, if the right index is the last array element, or if something is there in the right hand side. That's all. And if both are true, then only we're gonna insert the value. Otherwise, we're gonna skip it. And if we insert the value, we're gonna increase the count by 1 and mark the flower bed of that index to be 1. That's all. Now let's understand the code. Code is exactly the replica of the approach explained here. We declare a count variable. We loop through the flower bed. Right? If the flower bed of I is 0, which means we have a chance to enter one there. We're gonna check if it is the last index or if the I minus 1 is 0. Okay. Similarly, if it is the right side last index and or I plus 1 is 0. Okay. If both are true, then we're gonna make it 1 and increase the count by 1. And it will return if the count is greater than or equals to n. That's all. Now, the time complexity for this is O of n. Reason being, we are looping through the flower bed of size n, and space complexity O of 1 because we are not using any kind of data structures to store the answer. We are just returning a constant space variable and returning it. That's why. Let's understand the dry run. 1, 0, 0, 0, 1. Okay, n is 1. What our code is doing? Initializing count to 0. So count 0. Okay. Flower bed, if flower bed is 0. Okay. So here we are. We can see that flower bed of I of 0, it is not 0. So what we're gonna do? We're gonna skip. Nothing is going to happen here. We will come here. We will check if it is 0 or not. It is 0. Okay. First condition passes. Now we're gonna check left and right neighbor. Since it is not the starting index, so we cannot take that. Then we're gonna check if I minus 1 is 0, which is not. So that becomes false. The left neighbor becomes false. Now we will check for the right. It is not the last index, but I plus 1 is 0. Okay, so it becomes true. After that, what we do? We check if both are true or not. Since both are not true, we skip and we move ahead. We come here. This is 0. Okay. Again, we will check whether it is a starting index. No, it is not. Whether I minus 1 is 0. Yes, it is. Now we will check the right neighbor. It is the last index? No. Whether I plus 1 is 0? Yes, it is. So both becomes true. Left neighbor also and right neighbor also. Right? If both becomes true, we will insert 1 here and make the count 1. Again, we will come here. We will check that okay, the condition does not fulfills. We will go ahead, and similarly, it also does not fulfill. We will go ahead, and at the end we will check if the count is greater than or equals to n, which is so we will return true. If similarly in this case, if this n would have been 2, the process would have been the same. We would have entered 1 here only for the same array, but for 2 now for the another flower bed there would have not been any place, so it would have written false. Now let's go to the lead code and check out the solution. Let's initialize a variable and discuss count 0 for I in range for length of flower bed if flower bed of I is 0, which means we have a hope that left or right could be a 0 index and we can store the 1 there. So let's see if empty left plot equals to if it is a starting index or flower bed I minus 1 is 0, either of the thing. Empty right plot if I is equals to the length of flower bed minus 1, or whether it is the last index, or we cannot say that if I equals to if flower bed of I plus 1 is 0. If both are true, then if flower bed of I make it 1, and if for count we will increase the value and we will return count n. Okay, let's see. Okay, just guess password. Now we have successfully coded our solution, and this is our time complexity for lead code. So the code is available in my GitHub repository. Thank you, everyone.